In Chapter 8, we'll look at the I2C port on the device and the sensor library that we'll use to configure and communicate with it. In the lab, we'll use a code composer tool called GUI Composer to visualize the data transferred over the I2C bus from the light sensor on the educational booster pack. The TM4C 1294NC PDT has 4 independent I2C ports. Each port supports being a transmitter or receiver in both master and slave modes. Simultaneous master and slave operation is supported. Both the transmit and receive FIFOs are 8 entries deep. Operational speeds are 100, 400, 1000, and 3330 kilobits per second. Inputs are glitch suppressed and the module is DMA enabled. Note that each slave device on the bus must have its own unique address. Normally, this address is somewhat programmable with the use of pull-ups or pull-downs. The sensor library was originally written to support the SensorHub booster pack. This booster pack has 5 separate sensors, all connected to the I2C bus. The sensors include an infrared temperature sensor, an ambient pressure sensor, a 9-axis motion sensor, an ambient and infrared light sensor, and a humidity and ambient temperature sensor. This booster pack can be purchased using the part number shown at the lower right. The TivaWare sensor library includes drivers for the microcontroller I2C port, examples for each SensorHub sensor, and functions for manipulating the magnetometer readings. A direct cosine matrix or DCM sensor fusion algorithm is included that combines the 9 axes of motion from the motion sensor into 3 Euler angles of position. Example code reads the sensors and applies the DCM algorithm to the data. Also included are vector operations like add, cross product, dot product, and scale. All 3 development environments are supported and the driver library is under a BSD type license. Included SensorHub examples are the airmouse, which shows off the DCM algorithm, comp DCM under MPU 9150, which demonstrates basic data gathering from the MPU 9150 motion sensor, drivers for the buttons and LEDs, humidity under SHT21 to perform periodic measurements of humidity, light under ISL 29023 that uses measurements of ambient light to control the LaunchPad LED, pressure under BMP 180 to demonstrate air pressure and temperature measurements, and temperature under Temp 006 to periodically measure and calculate the temperature of an object. The sensor library provides a consistent programming model with the flow shown for all sensors, making it easy to leverage the library for other custom I2C sensors. The example shown is for the TMP006 infrared temperature sensor. First, the I2C peripheral and its pins must be configured. Second, the I2C driver can be initialized. Third, the TMP006 can be initialized across the I2C connection. Fourth, the TMP006 can be properly configured. At this point, data can be read from the device and converted into a temperature reading. Code Composer's GUI Composer tool allows you to create graphic user interface applications that provide visibility into your target code and the ability to control target variables. This can be done through the JTAG port, a serial port, or Ethernet. It can be used while debugging and as a Code Composer plugin, or it can be used as a standalone application through the serial or Ethernet connections. GUI Composer generates user interfaces that are comprised of a set of HTML5 widgets. These widgets are then connected or bound to variables or locations in the target system. When a control widget, like a dial or slider, has been connected to a target variable or address, any adjustments made to the widget will result in a change in that variable or location in the target system. For example, you could use a dial to change a variable that controls the speed that a motor is spinning. When a display widget like a gauge or graph is connected, then the value is read from the target system and the value is displayed in the widget. In Lab 8, we'll create a simple program to read the data from the light sensor on the educational BoosterPack across the I2C bus after we verify that the code is functional. By displaying the data in Code Composer, we'll create a GUI Composer display to show the data.